This is section 10.5, conic sections. So here are the three conic sections that we'll be looking at. We'll look at an ellipse, a parabola, and a hyperbola. So for parabolas, there's going to be one of four orientations. It's either going to open upward, open downward, open to the right, or open to the left. And they'll each have their unique characteristics for P and their equations, which will be down here. All right, so in general, an equation of a parabola with focus 0, comma p and directrix y equals negative p will look like this. And the parabola that opens to the left or the right will look like this. So this is either opening upward or downward. This is opening either to the right or to the left. So our very first example says find the vertex, focus, and directrix of the parabola and sketch its graph. So first we want to write it in the correct form. So if you solve for if you solve for x squared, you're going to get x squared equals negative 8/3 y. So all I did was isolate the x squared. That's because if you look down here, that's what we wanted it to do. That's what we need to do. So this is the equation that we're going to be using. X squared equals 4py, which means that negative 8/3 has to equal 4p. So we can write that equation. So 4p has to equal negative 8/3. And if you solve for p, that means p is going to equal to negative 2/3. So that's how you want to start this off, by finding what p is. Okay, they also want the focus. Well, let's determine which type of parabola this is going to be. So as you can see, p is negative, so it has to be one of these two because it's in the form of x squared equals, not y squared, and p is negative, which means it's this one, so it's going to open down, and the directrix is going to be in the positive on top. So it's going to look like this. If we sketch our parabola, we can begin to sketch it. Okay, it's going to open downward. The vertex is at the origin. Okay, and let's see, it tells us that the focus is 0, comma p, and the directrix is y equals negative p. So focus is 0p. Focus is 0p, which is negative 2/3, which makes sense because it should be down here somewhere. That is 0, negative 2/3, our focus. And then our directrix is going to be y equals negative p. Well, negative of negative 2/3 is positive 2/3, which makes sense because our directrix should be up here above. So y equals 2/3. All right, I believe that is all we needed to do. That is it. Okay. Moving on to the next problem. It says find the equation for the conic that satisfies the given condition. So they're telling us it's a parabola. This time it's not, the vertex is not at the origin, it's at 2, comma 3. All right, so let's begin to sketch this first to get an idea of what it's going to look like. Okay, so 1, 2, 3, 4. 2, 3, 4. So the vertex is 2, comma 3, which would be up here. The focus is 2, negative 1, which is down here. So in order for this to work, the parabola must open down because the focus is below the vertex. So it makes sense that it has to look like this. So we can even draw that in. Okay, this is our focus. This is our vertex. So right away we can determine what the formula should look like. Since it's opening downward, it's going to look like this. It's going to be in this form. So it's going to be x squared equals 4py. So x squared equals 4py. However, this is only true when the vertex is 0, 0. If it's not 0, 0, then you have to alter the equation. So it would be x minus 2 squared. I got the minus 2 from here. And then equals 4p y minus 3. And I got that from here. All right, now we got to determine what P is. Well, P, let's see how we can determine what P is. Well, P is just going to be the distance from the vertex to the focus. So all you got to do is subtract this minus this. And we already know that P has to be negative because of this. It reflects this type of graph, so we know that P has to be negative. So whatever this distance is, just make sure you make it negative. So let's see, that's going to be -1 take away 3 is -4. So P is -4. All right, so now if we substitute there, we're going to get -16, which is our final answer. X minus 2 squared equals, substitute, -16, y minus 3. And that's what they were asking for. They were asking for the equation that satisfies those conditions. And so that would be our final equation. All right, now they're going to give us equations for ellipses. So this is the ellipse that you would draw when A is bigger than B. So it's going to look more stretched out horizontally. This would be the equation that you would use for when A is greater than B, but A is under the Y this time, so it would be stretched vertically instead of stretched horizontally. Okay, so let's see. They want us to find the vertices, foci, and sketch. So 3 things: vertices, foci, and sketch. So in order to get it into the proper form, you need to divide by 225. So that's going to be, let's see, if we simplify that, that's going to be x squared. If you simplify that, what is that? You can divide by 25, so it's going to be 4 ninths. 4 ninths, but since it's in the, you can also write it as 9/4. All right. That way, you want it to be in this form. All right. And then the next one is going to be y squared over. You can simplify this 225 into 36 as well. You can simplify that, and you should get 25/4. So 25/4 equals 1. All right. So that tells us that our A is going to be 3/2 because you take the square root of A squared, and B is going to be the square root of 25/4, which is 5/2. And the way you get the foci is you need to use the equation c squared equals a squared minus b squared. All right, so in that case, it's going to be, let's see what we end up getting. We should get, we're going to get, let's see, a squared is, I think I got these backwards, don't I? Let's see. Yeah, I think I got these backwards, but it's okay. A is that one, and this one would have to be B. So that's going to be 25/4 minus 9/4, which is 16/4, which is 4. So C has to be plus or minus 2 after you take the square root. So you get plus or minus 2 for that. So now we can begin to sketch. All right, this is going to be centered at the origin. So we got 1, 2, 3. Okay, so in the y direction, we're going to go up 5/2, up and down 5/2. So that's 2.5. So it would be 2.5 up, 2.5 down. And in the horizontal direction, we're going to go left, right, 3/2 from the center. So that's 1.5 to the right, 1.5 to the left. So those are the vertices. Okay, and so we can even label those. So this would be 0, 5/2. 0, comma, negative 5 over 2. This would be 3 over 2, 0, negative 3 over 2, 0. All right, and for the foci, we said that it's going to be plus or minus 2 from the origin, from the center. So that means it's going to be up 2, down 2, because the major axis is the y-axis, because it's stretched out vertically. So that would tell us that our foci would be here and here. So that would be 0, 2, 0, negative 2. And that does it for this problem. All right. All right, let's move on to the next problem. Now they're showing us equations for hyperbolas. All right, so if the x squared term is positive, then it's going to look this way, horizontal hyperbolas. If the y squared is positive, then it's going to look like this, vertical hyperbolas. All right, so they want us to do the same thing. Find the vertices, foci, asymptotes of this equation, and they also want us to sketch it. So in order to get it into either one of these forms, you have to complete the square. So this is how you could do it. Let's group the y's together. So you got 9y squared minus 36y. Then group the x's together. Now you have to factor out a 9 so that you can complete the square. That's going to be minus 4y plus blank. We're going to have to complete the square, so I'm going to leave a blank to fill in the constant. And then for here, we're going to have to factor out a negative 4. It's going to be x squared plus 2x plus blank. Complete the square. So if you complete the square, that means you take the b term, you divide it by 2, and you get negative 2, and then you square that, and that's 4. So this is going to be plus 4, which is really 36. So that means you have to add 36 to the other side as well to keep the equation balanced. Over here, if you take the b term and divide by 2, you get 1. You square that, you get 1. So this is going to be plus 1, which is really negative 4 if you distribute. So that means you have to add negative 4 to the other side as well to keep the equation balanced. Notice these are going to cancel. These are perfect square binomials. That's going to turn into 9y minus 2 squared. This is going to be 4x plus 1 squared, and this is going to be 36. Final step would be to divide by 36 to make that a 1 on the right side. So that's going to be y minus 2 over 4 squared minus x plus 1 over 9 squared equals 1. Okay, so now we got the equation, and now we need to sketch and find all the other stuff that they were asking for. So let's begin with our sketch. Okay, so the center would be negative 1, comma, 2. Okay, so center is going to be negative 1, comma, 2. So that's going to be right there. That's our center. And then in the y direction, we're going to go up 2, down 2. So 1, 2. And down 2, 1, 2. And then the x direction, we're going to go 3 left, 3 right. 1, 2, 3. 1, 2, 3. And that's going to create a rectangle that I would do in dashed lines. And then there's the asymptotes are going to be the diagonals. And because the y term is positive, that means our hyperbolas are going to be vertical, not horizontal. So here are the hyperboles. There we go. The vertex is there and there. So this vertex is negative, what is that? This vertex is going to be negative 1, 1, 2, 3, 4. This vertex is going to be negative 1, comma 0. so we got the vertices taken care of. All right, now we got to look at the foci. So for foci, here is the equation that you would need to use for the foci. It's going to be c squared equals a squared plus b squared. So in this case, it's just going to be 4 plus 9. C squared equals 4 plus 9. So C is going to be plus or minus radical 13. All right, so the way we figure out what the foci is you're going to, from the center, you're going to add radical 13 for the top one and subtract radical 13 for the bottom one. So the foci, I'll write over here. It's going to be, the center is, we said, -1, comma 2. So it's going to be -1. So it's going to be 2, but plus or minus radical 13. The positive one is up here, or plus radical 13, and minus radical 13. So it's a little bit difficult to, I'm just going to draw it here, and then draw an arrow to that. So it's going to be -1, 2 plus radical 13. And then this one is going to be -1, 2 minus radical 13. Those are the coordinates for that. And the last thing we need is the equations of the asymptotes. So the way you find the slope is it's just the rise over the run. Well, the rise is up 2 and the run is 3. It's just the square root of these numbers. So here's your rise, square root of 4. Here's your run, square root of 9, which is 3. So our asymptotes are going to be, I'm going to create a little space. So it's going to be, we're going to do point slope form. So it's going to be y minus, it's the center. The center is y minus 2 equals m, the slope. The slope is plus or minus 2/3. All right, so the positive 2/3 is this one. The negative 2/3 is this one. X plus 1, because that's the center for the x coordinate. So that is it. We have our asymptotes, we have our foci, and our center. And we have our sketch. And that is the end of this section.